Hey guys, these notes are for parallel and perpendicular lines, our first section of notes for Unit 4. Our essential question is, how can you tell from two linear equations if the lines are parallel, perpendicular, or neither? In Unit 3, we talked all about lines. We talked about all the different forms: slope-intercept, standard form, and point-slope form. In Unit 4, we're applying them a little bit more and talking a little bit more about lines. So today we're going to talk about parallel and perpendicular. So what makes lines parallel? Well, the thing that makes lines parallel is if they have the same slope. So for example, if one line has a slope of 5 and the other line has a slope of 5, they are parallel to each other. And we'll kind of see this a little bit in Desmos. I'm going to be hopping back and forth with Desmos. I am going to make this video into two parts because we have a parallel section and a perpendicular section. And so I'm going to do a perpendicular and a parallel section video. So this part of it will be just parallel lines. All right, so we have 4 or 5 actually. We have one down there. We have 5 examples here, and we're asked to see if they are parallel and how we know. So the easiest form for me to recognize my slope in is slope-intercept form, which is y equals mx plus b. So I want to use y equals mx plus b for all of my equations here. So every single line that I have, I'm going to get y by itself so that I can identify my slope. It's really easy for me to identify my slope if I'm in y equals mx plus b form. So number 1, y equals 3x plus 4 and y equals 3x minus 7. Well, both of these lines are already in slope-intercept form, so let's go ahead and identify our slopes. Our slope for the first line here is positive 3. And the slope for the second line is also positive 3. Because these have the exact same slope, they're going to be parallel. And my reasoning is because of my slope. So if it says, how do you know? This is my proof. They have the same slope. Now, if they don't have the same slope, it can either be neither or it can be perpendicular. And we'll kind of talk about that a little bit later. So if they have the same slope, they are parallel to each other. And if you forgot what parallel means, by the way, it's basically two lines that never touch. So the way I like to think about it is, if I have parallel, you see those two L's in parallel? Right, I have two L's here, I have an L here and an L here, and they're parallel to each other. So they're never going to touch. All right, so number 2, my first equation is in standard form, and my second equation is in slope-intercept form. So my second equation is really simple for me because I'm like, hey, I already have it in slope-intercept form, so my slope here is negative 5 over 6. So I already know my slope for the second equation. However, for the third equation, or not the third equation, the first equation, I'm going to have to get this out of standard form into slope-intercept form. So I'm going to do this down here. I put a star next to it so that you know, hey, the blue is down here now. So you can draw an arrow if you'd like. All right, so our goal is to get it into y equals mx plus b form. So I'm going to go ahead and I'm going to subtract 5x on both sides because I want y by itself. 6y equals 9 minus 5x. And I want to divide everything by 6 as I'm trying to get that y by itself. So divide everything by 6. Well, 9 divided by 6 simplified is positive 3 over 2. And then negative 5 over 6 doesn't simplify, so we keep it the same way. All right, so what is our slope here? Our slope is negative 5 over 6. So do my two slopes match for my two lines? Yes, they have the same slope. They're both negative 5 over 6. So these are parallel. All right, number 3. Now these are both in standard form, so I'm going to have to move them both out of standard form. So go ahead and split my workspace here so that I have room to do both. I'm going to put the pink one, which I'm going to star on this side, on my left side. And then I'm going to put my second equation on the right side, 7x minus 3y equals 16. Now, it doesn't matter where my y-intercept is. It matters where my, what's it called? It matters what the slope is. So let me go ahead and actually plug in number 1 for you in Desmos. So y equals 3x plus 4 and y equals 3x minus 7. And you're like, why are you doing this? Well, I'm trying to show you to see if they're actually parallel. So y equals 3x plus 4. And if you're not taking notes, you are wrong. Y equals 3x minus 7, right? Is that what we got? I'm going to go ahead and change this to a different color so that we can see it a little bit better. Turn this to projector mode. Now look at my two lines. Do they ever touch? No, right? Even if we zoom out as far as we can, we still have two separate lines. They still never touch each other because they have the same slope. Same thing with number 2. Okay, in number 2, my line for the baby blue one, my equation was y equals 3/2 minus 5, 6x. Let me plug that one in. I'm going to go ahead and move my slope first, so negative 5, 6x plus 3 over 2. So again, that's my baby blue line over here that I'm graphing. And then I'm going to graph my first line, which was this one right here. Y equals negative 5, 6x plus 12. Y equals negative 5, 6. Whoa, what is going on? Y equals negative 5, 6x plus 12. Okay, so now I have my two lines, and they're in different colors. Now, if you're ever like really zoomed out somewhere far away in Desmos, you can hit the home button over here on your far right, and you just click it, and it goes away, and it goes back to your main. And see, these two lines are parallel. So in number 2, we have parallel lines. All right, so number 3, let's see if these are parallel lines. So I have two equations, and again, I'm trying to get it to look like y equals mx plus b. So I want my y by itself. So on this right side, or my left side, I'm going to subtract 7x on both sides. So I have 3y equals 8 minus 7x. And I'm going to get everything by itself. So I'm going to divide everything by 3. So I have y equals 8 over 3 minus 7 over 3x. So my slope here is negative 7 over 3. All right. And then let's go ahead and work out this left side over here. We're going to subtract 7x on both sides because we're still trying to get y by itself. We have negative 3y equals 16 minus 7x. And this time I'm going to divide by negative 3 on everything. Make sure you divide negative 3 by everything. So then I have y equals 16 divided by negative 3 doesn't really work out nicely, so I'm going to keep it as is. And then negative 7 over negative 3 gives me a positive 7 over 3. Remember, a negative divided by negative is a positive. So my slope here is 7 over 3. Are these slopes the same? They are not the same. And if they're not exactly the same, then they're not parallel. They have to exactly be the same. So even though they're just a sign apart, it's still not the same. It's not enough. All right. Now 4 and 5 are special. When I see something with 4 and 5, I always want to draw a graph. I want to draw a picture for myself. So if it's just a letter all by itself, like if it's just y equals a number or x equals a number, I like to draw a picture because it helps me visualize a little bit better. Okay, so let's do number 4 first. Now number 4, I have, I need to draw some tick marks, huh? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so I'm going to go ahead and make my first line, the pink one, which is y equals 3. And I'm going to graph that. Now, if I'm graphing y equals 3, then I'm going to be looking at my y-axis at positive 3. And it's y equals 3. And so this is going to be a horizontal line because my slope here is 0. And this is going to be my green line, y equals 5. That's going to give me a point on my y-axis at positive 5. And that's also horizontal. You always want to go in the direction of your tick marks. Or if you remember, hey, if it's y equals a number, my x is gone, so my slope is 0. So I have a 0 slope, so it makes a z with my x-axis. Now these lines are parallel. And the reasons why they're parallel is because their slopes are 0. Right, so slope on both is 0. So slope on the first one and the slope on the second one were both 0. And just to remind ourselves, remember we have z's. All right. Number 7, I'm going to do the same thing. I'm going to draw a graph for myself because I see just a letter by itself, and it always helps me to visualize a little bit better. All right. So I'm going to graph the first one in red, so I have x equals 1. So I'm going to look at my x-axis at positive 1, and you always want to go in the direction of your tick marks. You're going to go up and down here. And then for my second equation, I have x equals 6. So I'm going to actually have to draw another tick mark because I don't have another. And that's going to be at positive 6 on my x-axis, and that's still up and down. So these slopes are both what? These slopes are both undefined, right? So I have a u here. Whoa. I have a u. I can't really see. I'm going to do a u with that one. Okay. a U for undefined. So these slopes are both undefined slopes. So these are parallel, and the slope is undefined. All right. So these are our equations. Again, I can graph y equals 3 and y equals 5 in Desmos. And then just don't worry about all that other stuff. But see, we have two horizontal lines here. We have a black line and a red line. Or if I were to graph x equals 1 and x equals 6, oops, x equals 6. I have two lines, and they're vertical. They're undefined slopes, so they go up and down, but they never touch, so they are parallel. You have to have the same exact slope. If it's not the exact same, they are not parallel. All right, so now we're going to go into looking whether graphs have parallel lines or not. And here, you can't just look and be like, oh, well, they don't look like they're touching, so I guess they're parallel, right? So you can't just look at it and assume. You need the same slope. If you do not have the same slope for both of your lines, then they can't be parallel. So do the following graphs contain parallel lines? Well, let's check. We're going to do the first one first. And to find slope of graphs, we do rise over run. Right? So let's do rise over run. So I'm going to start with this line first in purple. So I'm going to rise over run with this middle point just because I feel like it. So I'm going to rise 1, 2, 3, 4. So I go positive 4. So my rise is 4 over my run, which is positive 1. So my slope here is 4 over 1. And then I'm going to go ahead and use this point down here for my second line, because I have two different lines here. I'm going to go up and I rise 3, and I run positive 1. So my slope here is rise 3 over 1, or 3. Are these slopes exactly the same? No. So they are not parallel, because their slopes are not exactly the same. All right, with my second graph, let's do rise over run again. So for my first graph, again, you can pick any point to do rise over run. I'm just going to pick this one. I'm going to rise, so I rise plus 1, and then I'm going to run plus 2. So my rise was 1 over 2. And I'm going to rise with this point down here for my other line. Remember, you're checking for two different lines. You're going to rise 1, and you're going to run positive 2. So my rise here was 1, and my run was 2. Remember, it's always rise over run. Let me put this in the middle. Yeah, I'll even put a cloud around it so we remember that with, what's it called? Graphs, we look at rise over run. Are these slopes exactly the same? Yes, so they are parallel because their slopes are exactly the same. All right, so the last part of the parallel line notes is just being able to write equations of parallel lines. So, 1, write an equation of the line that passes through the point -2, 3, and is parallel to y equals 3 minus x in all three forms. All right, so we got a lot of key words here. We're given a point, and we're asked to make it parallel to another line. Well, if I'm asked to make it parallel, it has to have the same slope. So it must have same slope. Okay, now it says we need to write it in all three forms. And the form that we always start with is point slope form. Point slope form, let's go ahead and refresh ourselves here. Point slope looks like y minus y1 equals m times x minus x1. We'll leave some room, and then the next form we go into is slope-intercept, which whereas y is by itself, so we have y equals mx plus b. And then we have standard form, which is ax plus by equals c. Now remember with standard form, you can't have any fractions. Your a has to be positive, and your x and y are on the left side. So let's go ahead and write this in all three forms. So first, we have a point. We're given a point of -2, +3. We're given a point. And then it wants it parallel to the line y equals 3 minus x. Well, this line right here right? We want it parallel to this. If it's parallel to this line, then it has to have the same slope as this line. Well, what's the slope of this line? Well, the slope of this line, remember, your slope is always attached to your x value. So the slope here is -1. So I need that slope, and I also have to have it go through that point, -2, 3. Well, I have a point and a slope, so I'm going to go ahead and plug it in point slope form. So my point slope form here would be y, and remember, we make sure we label, so let's go ahead and label. This is our x1 and our y1, and that's our m over there, which is -1. So we have y plus 3, oh, just kidding, minus 3, because it's negative, because you flip the sign, equals your slope, which is -1. And then you have x, and we're going to have x plus 2, because your signs are going to be opposite. Okay, so that's our point slope form. Well, from point slope form, we got to get to slope-intercept form. So we have y minus 3 equals -1 x plus 2. And to get it to slope-intercept form, I got to get y by itself. So here I'm going to distribute. I'm going to do -1 times x, which is -1x, or just -x. -1 times 2, which is -2. And I still need y by itself, so I'm going to add 3 to both sides. And I get y equals -x plus 1. Is this in y equals mx plus b form? Yes. So this is my slope-intercept form, okay? Because I have in y equals mx plus b form. My slope is still -1, and it needs to be -1 because it has to have the same slope to be parallel. Okay. Now we have to put it into standard. With standard form, I want to start and make sure that I have all of my x's and y's on the left. So in this step, I'm going to go ahead, I'm going to add x to both sides. Oh, whoops. I think this needs to be in blue still. Not that yet. I'm trying to color code my best here, so. All right, so here we're going to add x to both sides because we want them on the same, on the left side. X plus y equals 1. Well, I have no fractions and my a is positive, so this is indeed standard form. So these lines are all the same. They're all equivalent to each other, they just look different. Okay, so we have it in all 3 forms because that's what it asked us for. So I'm going to go ahead and plug this into Desmos just to show you that they're all equivalent. So the first one we had was point slope form. So we have y minus 3 equals -1 times x plus 2. Okay, so we have a -1 as our slope, which makes sense because we have a negative line here. Then we change this into slope-intercept, and we got y equals -x plus 1. If I click back and forth between black and red, they're the same line. They're just written in different ways. The third way was writing it in standard form. X plus y equals 1. What do you notice about all 3 of my lines? They're all exactly the same. So they're just different forms. And let's check to see if this is actually perpendicular to the original line. The original line was in purple. It's our highlighted purple. And so we had y equals 3 minus x. Let's go ahead and plug that into Desmos. Y equals 3 minus x. And let's make it purple to match our notes. So this was our purple line. Let's see if our line, which is in green, red, or green, blue, or pink, actually is parallel to that other line in purple. I'm going to go ahead and graph the green line in point slope. So I'm going to plug that into Desmos. Y minus 3 equals -1 times x plus 2. I'm going to make this green just like our notes. So the green line, is the point slope version, and the purple line was the original line, right? We're trying to make it parallel to the original line, and it has to go through the point -2, 3. Let's see if it actually does go through the point -2, 3. So let's look at -2. If we go from -2 to 3, yes, our green line actually crosses it right there. Okay, so it actually crosses at -2, 3. So that was right. Our green line goes through that point and has a slope of -1, which makes it parallel to our original purple line. All right, so that was probably a ton of information. So let's go ahead and do another problem with parallel. Number 2, write an equation of a line that passes through -1, 1, and is parallel to -3x plus y equals 5 in all 3 forms. Okay, so we know that it has to be parallel, which means that the slopes have to be exactly the same. However, the line that I'm given originally is over here, and it needs to be parallel to this one, and I got to figure out the slope of this one. And if you're saying the slope is -3, you're incorrect. And the reason why you're incorrect is because this is in standard form. We need to get it into y equals mx plus b form so that we actually have a slope that we can see. So with this, I'm going to add 3y to both sides. Not 3y, 3x. And I'm actually going to do that over here in the corner. So let me go over here. Negative 3x plus y equals 5. Again, I want it into y equals mx plus b. So I'm going to go ahead and write that up here. So we're going to add 3x to both sides to get rid of the x on that side. We have y equals 5 plus 3x. Okay, now, since I want the other line to be parallel to this one, I got to figure out the slope of this one first. The slope of this one is 3. So I want to use this slope in my new equation because I want it to be parallel. Okay, so I want it to be parallel to 3, and I want it to go to the point negative 1, 1. So our point here is negative 1, 1. Same slope. Okay, so the point is negative 1, 1, and we have a slope of positive 3, which we were given through our original line. We want it parallel to that purple one. So I'm actually going to go ahead and graph that purple one in Desmos so that we have it for reference. We have negative 3x, negative 3x plus y equals 4. So this is my purple line, and again, I'll change it to be purple just like our notes. Negative 3x plus y equals 4. Okay, now I want it in all three forms. So I always start with point slope form. Okay, and so my point slope form is y minus y1 equals m times x minus x1. So I'm going to plug that in. Y minus y1 equals m times x minus x1. Okay, our y1 here is going to be a negative 1 because our positive y value flips to the other side, or other sign. Our m is going to be 3, and we know that because we're trying to get it to be the same slope. So same slope so we can have it parallel. And then you have x plus 1. And if you're wondering where this is coming from, remember, this is our point. So this is our x1 and our y1. And when we plug it into point slope, our signs are opposite. Okay, so I have it in my first form, which is my point slope form. Go ahead and box that for my point slope. And now I need it in slope-intercept form. So I'm going to go ahead and copy this down again so that I have it to use and do some work. I need slope-intercept form. And slope-intercept form looks like y equals mx plus b. So I need to get y all by itself. But before I can, I got to distribute this 3 and get rid of these parentheses. Y minus 1 equals 3x plus 3. The last step here is to add 1 to both sides to get that y by itself. Y equals 3x plus 4. Now it's in y equals mx plus b form. Okay, and the last form that I need is standard form. So I'm going to go ahead and I'm going to start over here. So I have y equals 3x plus 4. And I want standard form, and standard form is ax plus by equals c. Remember, I don't want any fractions. I don't want my a to be negative, and I need x and y on the same side on the left. So I'm going to go ahead and I'm going to subtract 3x from both sides because I need to move the x over. So I have negative 3x plus y equals 4. Now this is almost in standard form. However, we don't want our a to be negative. So I'm going to divide everything by negative 1 because negative 1 doesn't change my numbers, but it does change my a to be positive. So the negatives cancel here and it makes a positive 3x. I have a negative y equals negative 4. And this is now in standard form. So I have my 3 forms. Go ahead and put an arrow to show that, hey, like I'm continuing up here. Okay, so now we have our all 3 forms. Let's check to see if it's actually parallel to that purple one we had at the beginning. And remember, I put it in Desmos earlier. And does not matter what form we pick. So this time I'm going to pick slope-intercept, our blue line, which is going to be y equals 3x plus 4. Was it plus 4? Yep. Oh, you know what? Silly. I'm so sorry. You're probably yelling at me through the iPad because I can't hear, but sorry. I typed in my purple line wrong originally. It should have been negative 3x plus y equals 5 because that's what we have in the problem. Okay, so we have negative 3x plus y equals 5. That's our purple. And again, all of these 3 forms in green, blue, and pink are all equivalent. And I'm just going to plug in the blue to check. And when I plug in the blue to check, which I'll change to blue, so I have my purple and blue lines, they are indeed parallel to each other, right? They never touch, so they are parallel. And again, If you really want to check to see if all of your equations are correct, you can type in your green, blue, and pink all into Desmos and see if they actually are all the same line. Okay, this is the end of the parallel video. Just remember, parallel lines have the exact same slope. Okay, your y-intercept may be different, but parallel lines have the exact same slope. Okay, if you have any questions, please feel free to come in and ask.